So here's a claim. Every integer is either even or odd. Or I'll put it this way. Cannot both be even and odd. And by the way, we've been using this fact like for 2 weeks without proof. Because my proof of the definition we have for even numbers is 2 times an integer, right? We know that evens look like 2k and odds look like 2k plus 1. But nowhere did we ever prove that these are actually opposites of each other. And how would you?
You probably just set it equal to each other.
Well, first of all, let's try it formally, and then we'll get to that. I like what you're thinking.
Okay.
So formally, what this is saying is that for all n and z, we don't have n even and n is odd. Yeah. So this is what we're trying to prove. Trying to prove this. This is our claim. Our claim is that for all n and z, that n cannot both be even and odd simultaneously. So let's do an aside. If we try to prove this directly, we are SOL like right away, in the sense that the only thing we really know about n, if we let n be an arbitrary / particular integer, well, all we know is that n is an integer. But it's going to be very hard to go from n's an integer to prove this, because we just have nothing. Like, you know, it's like we can't write it as like 2k plus 1 because you don't know it's odd. We can't write it as 2k. We don't know it's even. You know what I mean? We just know it's an integer. We don't know if it's prime or composite. We don't know if it's divisible by 3. We don't know anything about it. We just know that it's an integer. And so we have no foothold to rewrite it or do anything. It's really hard for us to do anything with it. But, let's try to prove it by contradiction. And remember, the way contradiction works is you assume, you assume the opposite, basically, right? So I guess, I'm sorry, this is not the claim. This right here is the claim. Well, I'll call it the false claim. This is equivalent to the witness saying she was taking a shower, right? It's the thing you're trying to prove false, right? So what you're going to do is, let's just assume the false claim is true. And so the false claim is that basically there exists an n and z such that n even and n odd. Well, if n's even, right, that means that n can be written as 2k plus 1 for some integer k. And if n is odd, I'm sorry, n's even means it can be written as 2k for some integer k. N's odd means that n can be written as like 2t plus 1 for some integer t. All right? If this truly happened, if there truly was n like this would happen. But then that would mean that 2k would equal 2t plus 1, set them equal, just like whoever recommended. I don't know if that was Toru, Brene, or Herman, or whoever that was. What can we do from here? Why is this ridiculous? Why can't this ever be true?
No number can be like one more than the number itself, if that makes sense.
Well, this
My
t
thought
and this
process
k
was
are
that we set
different.
it equal to k and k. That way we can subtract the 2k, and then we get 0 is equal to 1.
Well, the point is, though, we don't know that.
Right.
Like all we know is n is even and n is odd. We don't know that the k and the t here are the same thing. But you're on the right track. You subtract 2t from both sides. This means that 2k minus 2t equals 1, which means that 2 times kt equals 1. Divide 2 from both sides. You get k minus t equals 1/2. Here's the thing. K minus t, this is an integer. Right? Integer minus integer is an integer. So if this were truly true, that would be saying 1/2 is an integer, which is ridiculous. You see what I'm saying? So we're going to write this little sign right here. 1/2 is not an integer. So assumption must be false. So really, all we did here is we assumed the negation of our statement. We assumed the negation, right? This is like the claim. This is the same thing saying like the witness in the shower. Assume the negation, and then show the negation logically leads to this, something false. Therefore, by contradiction, the assumption must have been false. So this negation must be false, meaning the negation of the negation is true. So for all n and z, n can't be even and odd. We'll write that formal proof up next time. But how do you feel about this? Good? Bad?
I say good. Like you said, it's pretty much like kind of the same thing as what we were doing before. We're just kind of doing it with the contrapositive, I guess. I don't know. It seems pretty like similar to me, like to what we've been doing with direct proofs.
Yeah, contrapositive is pretty similar, right? It's just make a contrapositive, do a direct proof. Contradiction is a little different. This is a little different animal. This is where you're straight up just assuming that assume your statement's false. So you have this claim here, assume it's false. I'm trying to prove it true. But the way I'm going to prove it true is assume it's false. You're going to assume it's false and then show it can't be. Or basically, I'm proving this true by showing it can't be false. Prove true by showing it can't be false. Because if it were false, that would logically lead to 1/2 being an integer, or something ridiculous, otherwise known as a contradiction.
Got you. Makes sense.
Good? All right, well, mull that over. Think about that a little bit. We'll do plenty of these contradiction proofs because I love them. And we're going to probably do the most beautiful proof of mathematics tomorrow, or Thursday. And other than that, have a good day, people.
Thank you.
Bye.
You're welcome. Bye.